one of the main goals. So the home end of a home base strip or the origin of a non-home base strip. Okay, so the home end of the home base strip, meaning trip production, whenever you start or end in your home, that's the production for that zone. It doesn't matter which directionality is that. Is that clear? So whenever home involved in one of the anchor, so trip end important. Whenever trip end or trip leg, end means it could be starting leg too. So whenever you start from home, that's a trip production. Any side, either destination or origin. That's all production. So that means non-home base, if the origin of a non-home, now for the non-home base strips where home is not any anchor, okay, the origin point is your production. I will explain with an example very soon. So that means if I am going from here to the upper campus for a meeting, my production is this Sexton campus zone produce the trip. So only for the non-home base trip, directionality matters. And then then the Stably campus or the upper campus, that zone is attracting the trip. But the reason is the origin point is. But for the home, it doesn't matter. If even you are coming from your work to your home, it's the production for your home zone. It's not the production of your work zone. You got my point? Because you have to go home. Right? So this is another way of, like, simplified way to remember. Sometimes people get confused on that. And trip attraction is the non-home end of a home base trip. So that means, in this case, this zone, my Dalhousie zone, is actually attracting because non-home end of my home base trip. So it has a production, sorry, it has an attraction of one trip. So non-home end of a home base trip or the destination of the home base trip. So I think it will be, it might look a bit confusing in text. Just look at the example. So you can see home zone 1 and work zone 2. We have two home base trips, right? Home to work and work to home. And zone 1, meaning my home zone, have two production. Do you agree with that? Because any end, if it goes to home, that's a production for that zone. Because, okay? So it has a two production here. And for the zone 2, it has two attraction. Clear? Based on the definition. The same, this is a bit tricky. Look at this one. How many zone 1 is how many trips they are producing? I should have closed this. Don't look at it, but just think about and challenge me. So home zone is producing two trips because these are both home base trips. So whenever home base trip has an anchor of a home, that's a production for that zone. Clear? Simple. And for the work zone, you are attracting, this is easy, you are attracting someone to come to your zone, right? But this is sometimes uneasy. Say, this is this is not uneasy. This is also producing one because it's non-home based trips. So the end is here. So this is, so one production, one attraction here. But for this one, sometimes people say that, why two attractions? This is one attraction, this is clear. My school zone, my kids, I'm picking up my kids. So this is attraction, but why this one is also attraction? Right? Sometimes people might think, oh, it's actually sending a trip to home. But that's the definition, is the home-based trips. If there is one anchor of your home-based trip is home, that's a production for the home zone and attraction for the other zone. Clear? Okay. So these are just definitions. That the reason why we need to understand this, because we sometimes subdivide home-based work, home-based other, so we need to understand what kind of things. But the simpler kind of understanding is what we are trying to do is nothing but how much production of this zone, any zone, is how much production and how much attraction. So based on the definition, you will see most of the residential areas, zones that are in residential areas will be producing trips, right? That's their main job. So home is the producer, meaning all suburban areas the producer. And the downtown employment centers are the attractors. They attract, right? So that's the main take on to that. So the simplest way to generate this model is trip rate model. I'll go later on, but I will start with that discussion first. Trip rate model is maybe ITE. In the book you will see Institute of Transportation Engineers say put some sort of a table like this. Meaning, say for the single family land use, there should be daily trip rate is 9 trips. Their rate, how many people live, based on that, there should be a trip rate. So 2 trips, 5 trips, 10 trips for that many people. For a single detached house, so land use. So that another reason why we do this kind of classification, so that from the land use we can forecast. So you have a trip rate. How many trips? Number of trips. Number of trips for each zone is a function of, so number of trips produced by this zone is a function of a rate. So we have a rate, we can do that. But better way, the more effective way is this regression model. So we try to generate from our origin destination model. So production, so number of production in zone I and attraction in zone I, the way we do is function of some things. Now tell me, what are the productions should be function of? Based on the definitions. So number of trips produced in zone, what should be our typical suspect? That how we can get some sort of a regression, some sort of like what should vary or contribute, what are the factors for trip production?
Residential population.
Right, residential population. How many people live that zone? That could be one way of looking at it. What else?
Job density as well.
Not the production.
Right.
Right? That's the attraction. Right? So production, how many working people live there? Right? How many vehicles people? What is the vehicle rate, ownership? Right? Anything to do with the residential living. Right? Because production is ties to the home, like mostly. Right? So that's the explanatory variable that. For the attraction, job, number of jobs available in each zone, or number of floor space of retail, right? That will attract, like Mid-Bank Mall will attract more trips, right? Than any other zones, or Halifax Shopping Center. So floor space is sometimes, it can be useful. So these are the suspect, but we have to do that from data, like see that what are the functions for that, right? So this is just the definition of what I explained. So the typical regression model which fits the linear relationship, sometimes you can do it in Excel as well. You don't need the ME to do that, for example. So what it is, daily trip production per household for all purposes. Purposes mean all trips, which can be, say, as a function of number of vehicles per households, or number of people. Like I'm just putting so that there should be a constant and there should be a variable. Whatever variable we choose or we find from the data, we have to find out from the data. That's what it is. Daily work trip attractions for a given zone is total zonal employment. So this is just an example. Like I have an example. And So total number of trips in the production stage or as a generation stage is based on the zonal attributes, right? So as long as we have a zonal attributes, we are fine. Either from a traffic origin destination survey, or it could come from just census data, right? It's easy for the census data, you know, like everything is there. That's why I was saying we try to align our traffic analysis zone, because some municipality might not have travel surveys. It's costly. It's a hugely costly, $1 million, sometimes like thousands of dollars that you get a random sample. Sometimes they might not have that. So we can use the census data.
Question about that. I just looked at Halifax's traffic zones, and they don't link up with the dissemination areas or with the CTs. Somewhere in between.
It's more dissemination area, but a little bit more we segregate in some areas to align with some major routes.
Right.
Because in traffic analysis zone, another consideration we have to do is we try to separate by some roads so that we know the loading areas separately. If a road runs through or edge of the traffic analysis zone, we lose that detail piece. So we try to readjust from the dissemination area.
So the analyst would just assume that the zone bled into, you know, whatever data they had, whatever variables they had for a DA would bleed into the area that they were adding.
No, we do. That's a good question. So even zone determination requires some sort of analysis. We did that, like some sort of analysis, like where it make more sense traffic analysis zone to put, what kind of decision we need to do in the future. So there are a lot of consideration. But for your specific question, like how people merge, say, from dissemination area data, for the travel survey data, it's easy because we collect all the coordinates, so we can easily know who belongs to which zone from the traffic survey, so travel surveys like the TTS or the Novo track that we are doing. But if we don't have, say, those data, we rely on the census data, then we need to do what we call a weighted average. So you have to go through some weighted average in GIS. You guys probably have done that. So we try to do the weighted average of like who most likely to be there. So that's why we usually try to do as much close to the dissemination area, but sometimes we can't.
Yeah, so you have that survey and you're not entirely reliant on sticking to what's in the
Right. So this is more zonal activities. So this is again recapping what I already asked you. So for the production or home end variables is population by type. It could be working population because that's the production is all about. And production is not only working population. This depends. If you are only production for work trips, then working population. But more family, like number household size is important for your, like putting your kids to the school, right? So depending on number of workers, number of auto ownership, income, usually income, like we found, like the more people have more income, the more people do travel. With more car, they do travel more, so those kind of things. Distance from CBD, Central Business District, which gives us a sense of whether you're in urban core, suburban area, or rural area. It has travel behavior changes. You saw those in my second lecture, like the general interpretation. But here we have to just find out which variable actually explain better in a specific metropolitan area. From the data, we just plot, like how many trips from our travel survey. How do we do that? Anyone, how do we generate a linear regression established from a travel survey? Exactly. So we know number of trips for each zone from our travel survey, right? Sorry. Okay. Just a second. So what do we know from a travel survey? How many trips generated for each zone? From our census data, we know population of this zone, income of this zone. So what we do is our dependent variable is number of trips generated by each zone. Our independent variable in Excel or any other statistical software, we put all those variables and try to see statistical significance and try to get our model. Like usually we try to keep it very simple, not too much for the practical ones, not for the research one. Very simple, and so that like usually number of population or attraction, employment, floor space, we try to get that. So we get that relationship, we apply for it. Then we apply to get the future generation, future number of trips. So that's the industry standard way of doing it. But sometimes people also try to more simplify things. Like I told you about, let's do that one. More simplify is the trip rates. Simply trip rates. Each land use type in each zone, this is a residential, this is the percentage of single detached, then you just apply a rate that from various studies, ITE, like observed and say, oh, that's the rate per dwelling unit. You got my point? So what is the production? Is per dwelling unit. We have that rates, we apply for the attraction. There is a trip generation manual. Every year they update, and so sometimes like if you don't have the data, you just apply those. Okay. Another intermediate between this very simple trip rate method and this regression method is which we call cross classification analysis. It's another method. You can choose any of them, in which we just don't rely on the trip generically, but we try to segmentize with say household size or number of cars and try to see separate trip rate for each segment. Say if I have a single person, the trip rate is different than a couple with children, right? So that's the rationale. So we need to have two different kinds of rate. And this is also easy to establish. It's a cross-classification analysis, as you can see from this example. It's in the book as well. So, say for example, from one of the survey, we know that for the automobile ownership, 0, 1, 2 or more, and family size, 1 person, 2 person, 3 person, 4 person. Please look at these examples. We know how many number of households in each zone, or in the entire region, not in zone, in the entire region, and we know number of trips for each category. So we plot them, we put in the table. So say for example, 2 or more, number of households is 121 for that entire region, and they are making 206 trips, right? So we just put them on those columns and try to get each of segments trip rates. Say for the 0 car, 1 family is 1.19. Right? The same way, 5.05 is you have a 2 or more car and 4 or more people in our households. So we get that. So it's much more, a little bit better than a region-wide trip rates, isn't it? So we can do it in different ways, just not the family size or mobile size, whatever data we have. So data dictates. Like if we don't have a travel survey, we can't do linear regression, isn't it? Because we don't know the number of trips from census. From census, there is no number of trips other than just the work trips, right? So we don't know that. So depending on the data, we choose our method, right? So and then this is the application, forecasting application. Say in a future zone, say Bedford West was not present 5 years ago, or this Blue Mountain subdivision, right? We talked about, like, we don't know what will be the trip pattern. So easy way is, at least we might know what will be the number of population. Maybe there is a forecast, there will be 3 household car, or 1 family, how many family number. Maybe we know the population, so we plot them. and we try to multiply it with our rates to get total number of trips. So that's how we produce. So this is another way of knowing how like our impact, traffic impact. Is it clear? I would strongly recommend everyone to go through this exercise. Without this, try to really understand like how we can apply in different kinds of scenarios of this kind of concepts. Is it clear how you can get your number of trips generated, either produced or attracted by each zone? So you can do the modeling for the trip generation. Okay? So trip rate models, we already talked about it. So trip rate models is also useful for sometimes for special areas, say shopping mall. Like sometimes our generalized model will not capture, say, Halifax shopping malls total. So when you look at the the zone where Halifax shopping mall is, you will see that from our generalized model, it is not really, it is underrepresenting in the Mumford Terminal zone. Then we sometimes adjust with also some trip rate malls or a specific, because it's a special area. Sometimes we might miss from our generalized model. Whenever we are averaging things, right, we are losing. We are losing the key details. Like for example, if I just take average age or income here, it might not be reflective of like what was in here. So any generalization of the model could sometimes could be misleading. So we try to do those kind of what we call calibration or validation. We try to really see whether it makes sense in each stage of the model, just to see whether it makes sense. Okay? So that's generally trip rate model. Before I go to the next stage, I would like to give some break, 10 minutes. Any question thus far for the trip generation? No? Okay, sounds good. 10 minutes break.